All right. We seem to be stabilizing on the number of participants. So I just wanted to welcome everyone and thank you for joining the second of 9 lectures on this virtual PhD course on urban economics in developing countries. This course is hosted by the International Growth Center in partnership with the Bureau for Research and Economic Analysis of Development. And we are, really excited to have such a kind of diverse cohort of people joining us from all corners of the world. I think last week, or I know we had registrants from over 100 countries, and I think last week we had about 800 participants joining. So I feel we might be the largest and most nationally diverse group of urban economists to come together and learn. And indeed, learn we must. So if you haven't gathered from my Zoom name already, I'm Oliver Harmon. I'm an urban economist at the International Growth Center's Cities That Work initiative. I'm going to be chairing today's lecture, which will be focusing on migration, or indeed the pull of the city. And to teach us something about this, we are very grateful today to be joined by Garrett Bryan, who is an associate professor of economics at the London School of Economics and Political Science. He is situated one floor below me. Garrett is also the research program co-director of IGC Cities and an affiliate of BREAD. We're also very fortunate to be joined by Melanie Morton, who's Associate Professor of Economics at Stanford University, many miles away from me. Melanie is also in the executive committee of BREAD, and both together and individually, Garrett and Melanie's work has indeed contributed to my understanding of migration in developing countries. So on a personal level, I'm very much looking forward to this, and hopefully you will be too. So I have 1 or 2 more housekeeping items to get out of the way before I move aside for the main event. This lecture will be about 1 hour, and it's broadly going to be delivered by Garrett, and then Melanie's going to be both responding to the questions in the chat as best possible throughout, but specifically is going to be engaging more on the sort of 20 to 30 minutes of Q&A after the lecture. Indeed, I think some people who were here last week know this next point, but if anyone would like to act as a live participant in this lecture, meaning you will have access to both microphone and video and can interact verbally during the Q&A, please virtually raise your hand, and my glamorous assistant, Greg, in front of me, our technical assistant, will randomly select a few of you to join the discussion. As an incentive as well, I will come to these live participants first for the Q&A, so I do think there's some merit in having your videos on. But for other participants who, for various reasons, do not want to necessarily have their mic or their video potentially live, you of course can type any questions migration related into the Q&A box at the bottom of your screens. You can submit these questions at any point during the discussion, and it'd be great if you can include your name and organizational affiliation when you write these up. I would also come to the questions that have been upvoted most by the cohort, so please upvote any questions you think are particularly interesting or you particularly like to see answered. As you can imagine, we are recording all these lectures in these series, and these recordings are going to be available on IGC's website, where most of you signed up, as long as the slides and the reading lists for these lectures. And importantly, to note, for those who attend at least 7 of the lectures in this series, you'll be issued with a certificate of completion of the course, which I know is important. Okay, that is all from me. So without further ado, I'd like to hand over to Garrett to lead off with this lecture. Garrett, the floor is yours.
Thank you for that kind introduction, Ollie, and thank you for everyone coming along. As Ollie said, I'm going to talk about migration for about an hour, and then I'm going to hand over to Melanie, who's going to answer your questions. So I'm really just going to try to achieve 2 things in this hour. First of all, I'm going to try to motivate you that studying migration is both interesting and important. I'm going to try and do that very briefly. Then I'm going to suggest that urban economists and development economists traditionally respond to questions about migration in very different ways. So I'm largely a development economist, and what I might do is go to a developing country, Bangladesh. I would collect my own data, and I might do a randomized controlled trial where I try and encourage people to move into a city, and I might see what happens to them. And that allows me to have a very precise answer to quite a small question. Urban economists, on the other hand, tend to use models. They would make some abstract more or less abstract assumptions about why people might migrate. They would gather a little data to try and calibrate that model, and they would use it to try and answer questions. They might use it to try and answer very large questions. For example, as climate change happens, where are people in the world going to move to in response to that? That's a migration question. And really what I'm going to try to do in this talk is argue to you, and maybe try to get you to, I'm going to argue to you that there should be more work that combines the two of these things. Those large models of urban economics are great, and they do wonderful things, but we need more realism from on the ground in developing countries in those models. On the other hand, randomized control trials are wonderful, but they might not be able to answer the big questions that we have. Okay, and I'm going to do that by outlining a model of migration and just talking you through how it works, showing you why it's great, but also criticizing it a little bit. It's from some work that Melanie and I did some years ago. Okay, so first of all, I'm going to start with motivation for thinking about migration. And I've got a few of these, and they're just big pictures. So this is a plot. On the x-axis is GDP per country, and the y-axis is the share of the population living in an urban area. This comes from UN data. And I guess many people will be aware of this correlation. Richer countries are more urbanized. And it's tempting to have a look at this and think, well, if I could take Tanzania and I increased its urbanization rate from about 30% to about 80%, how far would it also make the trip towards the USA in terms of GDP per capita? That is, if I caused urbanization, would I also cause growth? Of course, it's also possible that growth causes cities rather than the other way around. Related to this, I might ask, well, in order to get the urbanization rate of the United States, would that require migration? Or would that simply happen because people are born in dense environments and those environments get denser and denser? We're going to need to think about that through some models. Here's a second motivation. It's related. On the left is productivity per worker, output per worker in agriculture in red and non-agriculture in blue. And on the bottom, in the x-axis, is non-agricultural labor share. Might know that rich countries have few people in agriculture, so they're on the right of this graph. And poor countries have lots of people in agriculture, and so they're in the left of this graph. And what you can see is that developing countries put the majority of their workers into the sector that they are relatively worse at. So people in Uganda predominantly work in agriculture, but Uganda's agriculture is a long way below New Zealand's agriculture. But Uganda's non-agriculture is nowhere near as far behind New Zealand's non-agricultural sector. To the extent that agriculture and non-agriculture are extremely highly correlated with urbanization, then in order to move between agriculture and non-agriculture, we would need people to move across space. On the right is a picture of wages across different regencies in Indonesia. And again, what you can see is that wages differ vastly across space in Indonesia. It is true that on average, urban wages are higher than rural wages, but there's still a huge amount of variation even within rural wages. That suggests an additional interpretation, which is perhaps even within agriculture, people are in less productive places than they could be. Would moving people across space improve that? Of course, there's many explanations for these sorts of graphs. I've emphasized they might be caused by constraints on migration, but they could also be related to selection or amenity differences. Maybe cities are productive, but horrible places to live. Okay. This is another picture. I'm sure people have seen pictures like this before. This highlights a couple of things. These are night lights, and we think that night lights are a relatively good measure of productivity. Let's start by looking in Europe and the United States. One thing you'll see is that there's lots of bright lights, but the second thing you'll see is that they are regionally clustered. That means there are cities, and cities are the places that have the brightest lights. If you zoom in, you see that a little bit more. The second thing I'd like you to see is that Africa, for example, is much darker. It has a much lower GDP per capita, but it also has far fewer obvious cities. So is it that Africa has far fewer cities and lights because there's low productivity in Africa's cities? Or is it perhaps because people can't get to those cities? Is it because they can't migrate? Here's a fourth motivation. I've called this urbanization is coming. This is the UN's projections of urbanization until 2050. We're currently sort of to the right in this picture. And usually people think about two things when they see this picture. First, let's take Africa. And this picture tends to say that Africa is much less urbanized currently than is, say, Europe, a wealthier country. And that there will be a lot of urbanization between now and 2050 in Africa. That has a cost. Those people who move into the city will need to be managed. Perhaps we would want to stop them from moving into the city, and you hear that comment a lot. But you could also ask, will that be accompanied with a boom as they move to a city that might be a more productive place to live? Finally, this is variation in the predicted incomes on crop yields in Africa from a lovely paper by Bruno Conti. What do you see? Well, climate change is going to have very geographically diverse impacts. Some places are going to see crop productivity drop, and some places are going to see crop productivity go up. How should we interpret this? Well, one interpretation is climate change isn't going to be the problem that we thought it was. People should just move away from the red places to the blue places, and then there won't be such a big drop in productivity. An alternative interpretation that you read a lot in newspapers is that one of the negative effects of climate change will be that it causes a lot of people to have to migrate. I quite like migration, so I don't think it's a negative, but I think a lot of people do. But if we want to know which of those it's going to be, we're going to have to study migration. Okay, so there's some motivation towards thinking about migration. And as I said, I'm going to try to think about most of these issues through the lens of a spatial model, tell you what that model, how it works, what it can achieve, and also suggest that perhaps we need more work in developing countries to really make those models correct for the settings we want to use them. Okay, so I'm going to divide my talk into what you get out of a model into four things, four purposes for a model. There are some other purposes, but here's four things I'm going to talk about. If I had a model, I can use it to measure things. That's one of the primary reasons why we create models. So for example, I could ask the question, how costly is it to move across space? Is it more costly to move across space in Uganda than it is in New Zealand? If it is, perhaps that could explain why so many people remain in rural agricultural areas in Uganda. The second thing I could use my model for is just an interpretation. So we talked earlier about the lack of cities in Africa in the nightlights data, and we could ask, why are there cities in Europe? Why are there no cities in Africa? And in general, why are there cities? And we can use a model to do that. The third thing we might like to do is to make some predictions. Here's the one that I'm going to talk about. Where will people move in response to climate change? They might move from those red areas to the blue areas, but I would like to know where they're going. I'd like to know for two reasons. First is a positive reason. Where should we as a society be prepared for migrants to arrive if we need to make preparations? The second is a normative reason. What will be the cost to those individuals of moving? And will movement in general reduce the costs of climate change, as I suggested it might earlier? The final use we could put this model to, or I'm going to talk about, is we could think about policies. Some of the big policies, i.e. what ought we to do about some things? And the one I'm going to think about is a very big question, which is, are people in the right place? More specifically, are cities likely to be too large or too small? This is a comment that I'm often asked. Should we have secondary cities? Should we try to stop people moving into Africa's large megacities? And I'll try to use the model to think about that. And again, as I will for everything, I'll argue that we don't quite know the answer and we need more data from all around. Okay, that's where we're going. Okay, so first of all, I'm going to outline some of the model, and then I'm going to tell you how you can use it to measure migration costs. I'm going to show you that it looks in the data like developing countries do indeed have higher migration costs. So let's go. Okay. So the class of model I'm going to talk you through is a spatial equilibrium model. And spatial equilibrium models are the basic way economists think about urbanization and migration. Here's the basics of what happens. The world is divided into some places, and those places each have characteristics. For example, San Francisco might be more productive than Michigan because it is on a harbor. It might also have higher amenity because you can see the beautiful water. But San Francisco almost surely has higher costs of living. And if you're going to move to San Francisco from Michigan, you'll face some costs, some transport costs of getting there, but also if you won't be living near your family anymore, you'll have costs of being away from. And these place characteristics, they could be exogenous, as I've just suggested, but they could also be endogenous. As more people arrive, for example, rents rise, and so costs of living go up. Now, people migrate in response to these utility differences across space, and we think that there's a spatial equilibrium when a marginal migrant is indifferent. There's just some person who's thinking, maybe I should live in Michigan or San Francisco, I'm indifferent, and everyone else is happy with where they are. And we can consider what would happen after a shock, for example, a productivity shock in some city or a climate shock. And well, that would change the characteristics of some locations. People would move, and they will only stop moving once we have, again, that equilibrium condition that the marginal migrant is indifferent. And this could happen because of selection. So I have more people move from Michigan to San Francisco, and slowly I move down till I get to the sort of people who really don't want to live in San Francisco, and they stop moving. Or it could be because endogenous changes to the wages, amenities, or cost of living, as I talked about earlier. Rents rise. That stops people moving into San Francisco. That's the basics of a spatial equilibrium model. Now let me be a little bit more specific. Hopefully this is simple enough. So we can think of the world as, or a country, as having lots of locations, and those locations could either be O, an origin, or D, a destination. If I was born in Michigan, my origin is O, and I'm thinking about going to San Francisco, my destination is D. But if I was born in San Francisco, that's my O, and if I'm thinking about going to Michigan, that's my D. And we're going to think about locations of having the following specific characteristics. So a destination has a kind of wage per unit of human capital. How much would you earn per unit of schooling if you went there? An origin has schooling availability. If I grow up in rural Bangladesh, I have relatively little access to good education in comparison to if I grow up in a city. Every destination has rents, how much I would have to pay for housing. It has some amenities, like are there lovely parks, or is it really badly polluted? And then there are costs of getting between location O and location D. So we're going to put these all together into an indirect utility function. So a person I who moves from O to D has the following indirect utility. Things on the top are positives and things on the bottom are negatives. So you want to move to a destination where there are high wages and high amenity, and you don't want to move to places where there are high rents and high costs of getting there. Okay. Now I've introduced this little shock here, epsilon OD. This is an individual's heterogeneity. We don't all agree on where would be the best place to live. Some people like a harbor, and some people like to be cold all winter, and they live in Michigan. Okay. You'll see after the equal sign there, I've suggested that I could summarize the characteristics of a place, D, as this VD, the indirect utility of living at D, which is a summary of wages, rents, and amenities. Now, you might ask, and I'm going to try and talk a little as we go through, why this particular functional form? Why is rent dividing wage rather than, say, subtracting from wage? And the simple answer here is we're going to get a very tractable model out of this assumption. If we're going to build models, we're going to have to be able to make them work. So we have to make decisions that are going to lead to tractability. And I'll show you that in a second. Okay, how does this very simple model work? Well, let's think about two locations. We have a rural location and an urban location. And perhaps as befits many developing countries, everyone, I'm going to assume, starts being born in a rural location. On the left, I have a picture of these shocks, these epsilon shocks, one of which is mislabeled as epsilon B. But on the y-axis, I've got the value of your urban shock. People who are high here really like or are really productive in urban areas. And then on the x-axis, I have the rural shock. People who are high on this axis really like or are really productive in rural areas. Now, people migrate from the rural area to the urban area if the value that they get from living in the urban area, net the costs of moving from their origin to the destination, are greater than the value of staying at home in the rural area. And there's no cost of staying at home. So on the right-hand side of this inequality, there's no cost dividing through. I can rearrange that a little bit, and you can see that all the people in my diagram who are above the line that I have drawn are going to decide to live in an urban area, and all the people who have a shock below the line are going to decide to live in a rural area. Okay. I can then try and use my model to have a think about what happens if there's a change. Let's suppose, for example, that there's an increase in the productivity of living in an urban area. What's that going to do? Well, it's going to push up the wage per unit of human capital in the urban area. That's going to mean that the indirect utility of living there increases. And so all the people now above the blue line are going to decide to live in the urban area. And that's our new equilibrium, where marginal migrants are indifferent between where they live. And you can start to see that I can use a model like this, if I knew the distribution of all the red dots, to make predictions about what would happen in responses to different kind of events, like increases or decreases in productivity. Okay. Now, if I want to be a little bit more precise about that, I can't use a model of an individual to take to data. I need a model of an aggregate groups of people, because what I know about things like migration is aggregates. How many people born in Michigan moved to San Francisco? Not did Ollie move from Michigan to San Francisco? So we're going to use our model to try and build up to some aggregates. We're going to do that as a following way. I've got this shock. For every destination, I have either a taste or a productivity shock epsilon that differs across people. And I'm going to assume that it's drawn from a Frechet distribution. Why? Well, I'm going to go to the place that maximizes my utility. And it turns out that the Frechet distribution is closed under maximization. What does that mean? It means if I take the people whose maximum place to live was Michigan, then once they have arrived in Michigan, the distribution of their epsilons will still be Frechet distributed. That means I can know the distribution of all the dots in these diagrams. And that's going to mean I can try to calculate how many people are between different areas like these lines. Okay. We could have made other assumptions, and you'll see other assumptions in the literature. For example, you can assume it's Gumbel and you get a slightly different one. Okay. If we make that assumption, we get this very simple equation. The proportion of the population who was born in origin O and decides to live in destination D is just this fraction. On the numerator, the higher is the indirect utility of going to destination D, the more people will go there. And they won't go there if it's costly to move. I want to draw your attention to three things here. First of all, this has a gravity form. People are drawn to high indirect utility locations or destinations, but that pull, that gravitational effect of big, wealthy places weakens when you're further away from them, like it would with gravity. And we know this sort of gravity formulation fits data very well. The second is the parameter theta measures the dispersion of your preferences or your productivity. So if theta is very high, it means that these red dots are quite close together. People don't care if they live in a rural or an urban area. They kind of have the same preferences over both of them. If theta is very low, then the opposite is true. We have a lot of dispersion. And that explains why theta gives you the elasticity of migration with respect to changes in things like productivity and amenity. So the more dispersion we have in our preferences, the less we agree where it's a good place to live, and the less we will respond to changes in productivities or amenities across space. Third, human capital is irrelevant in this model for where you choose to live. Doesn't appear H0 is not in these things. That's partly because of the way we have modeled it. And there is a paper by Sam Batsy, 2016, that suggests that's incorrect, but also a recent paper by Alan Shao in 24 that suggests that that is correct. But that's just a feature. Finally, in the denominator, I have this object I've called phi O. It's a fact about your origin, and it summarizes how much access you have from your origin to good locations to work. And people who are born in locations with high access will have high welfare because they can easily get to locations that have high productivity and high amenity. And people who are born in places with low access will have low welfare. Okay. That's my simple model so far, and it just tells you how people migrate across space. Now let me show you what you might use with it for. So I'm going to take this extraordinarily simple equation, the pi OD equation, and I'm going to play around with it a little bit. So if I told you on the base here, there is this phi, this access of everyone who is born in location O. And it's the same for everyone that's born in location O, regardless of where they decide to live. So if I take the proportion of people born in origin O who stay in origin O and divide it by the proportion of people who are born in O and move to D, that phi cancels out and I'm left just with V's and costs of movement. I can do that for another location as well. Let's call it D, and I get a similar expression. Okay. Now, taking those two expressions, let's assume that the cost of moving from O to D is the same as the cost of moving from D to O. A person who goes from San Francisco to Michigan pays the same cost as a person who was born in Michigan and goes to San Francisco. If that's the case, I can take my two equations and I can multiply them together, and I can get a measure of the cost of moving from an origin O to a destination D. It's this ratio of migration probabilities. The proportion of people who move from O, the proportion of people born in O who stay in O, multiplied by the proportion of people born in D who stay in D, etc. Now, this data on the proportion of people who stay at home versus go to different places is quite common in censuses. I know people's location of birth, often down to a district type level, and I know where they're living in a census. Now, I don't often know the theta, and I'm going to kind of punt on it, but let's suppose it doesn't differ across countries. Then I could use this equation to rank countries by how costly it is to move between O and D. What I would do is I would say, well, let's suppose Michigan and I would try to look at how this cost of movement increases with the distance between O and D. And I would say that a country for which the cost of movement doesn't increase much with distance has low movement costs, and a country where the cost of movement increases very rapidly would have high movement costs. Okay, this is called the Head-Rice Index. So now we can do the exercise of trying to ask through the lens of the model whether developing countries have higher migration costs than the developed countries. And here is the answer. This is just based on census data from IPUMS. So on the bottom right, we have the United States of America. It's wealthy and it has relatively low migration costs. America has very well integrated labor markets. On the left of the picture, we have some developing countries. We have Malawi and Tanzania. They are much poorer, and our method suggests that they have much higher costs of moving across space. This then leads to a question. We know that they have higher costs. This would mean that people may be misallocated across space with respect to where they are most productive. Perhaps more people, because people in Tanzania face a higher cost of moving over space, they will be more likely to stay in their origin, which will be a rural agricultural area, than if they had been born in a richer country. Now, one limitation of this is we don't know what these costs are. Here's two options. Given this equation that I've got here, it could be that these are credit market failures. If I want to move, I have to borrow some money. I'm going to have to pay for bus fare, and I'm going to have to be without a job while I look for a job in a city. Those credit market frictions we usually think are larger in a developing country. And if that's what is reflected in this diagram, then we would think that there are policies that would improve people's migration by helping them get access to credit, and would then reduce spatial misallocation. People in Tanzania would move into the city, and maybe they would then get access to the higher wages that I showed you earlier are in the city. Of course, it could be that these costs are policy irrelevant. Maybe the people of Tanzania just really like staying where they are born relative to the people of the United States. It seems convenient that it's ranked according to GDP per capita on one of those sorts of explanations. Okay, so that's one use of our model to try to measure things and summarize what's difference between developed and developing countries. The second thing I'm going to look at is, can our model help us to understand why there are gaps in wages across space and why they're particularly prevalent in developing countries? Okay, for this we need to adapt the model a little bit. So I said earlier that this epsilon shock, I've got an epsilon shock for San Francisco and I've got one for Michigan. This could either be a preference or a productivity shock. Let's assume it's a productivity shock. What does that mean? That means the wage of individual I, born in origin O, if she moves to destination D, will be equal to the productivity per unit of human capital in her destination, multiplied by the quality of schooling, HO, from her origin, and then multiplied by her shock. And if we make that assumption, we can use this magical idea that we have a fresh air distribution conditional on where you choose to live to get a summary of the average wage of someone who is born in O and moves to D. And here are the equations. I'm going to point out a couple of things with them. Take the first equation, where the average wage of someone who moves from O to D is a function of the cost of moving from O to D. The higher is that cost, the higher the wage. It's a function of the amenities and cost of living in D. The higher are those, then the lower will be the wage. Good. And then it's a function of some things that are just about the origin. And what you will see most predominantly here is that this wage does not depend on the productivity in the destination. So, conditional on being in an origin, it doesn't matter where you go as to what the average wage of people is. Why is this the case? Let's suppose I have a group of people living at a destination Diddy, San Francisco. And let's suppose that there's increase in productivity in San Francisco. Well, that increases the wages of people who are from Michigan who were already living there. Great. But more people from Michigan move in to San Francisco, and those are people who are relatively less well suited to living in San Francisco than the people who are already there. So we have one positive effect and one negative effect. And this fresh air distribution we have implies that these are balanced. This then gives us a very strong interpretation of spatial wage gaps. We can only have gaps in wages across space we will have no gaps in wages across space if there are no movement costs and if there are no amenity differences across space. The only way we can get spatial wage gaps is if there are either or both costs of moving across space and amenity differences in different places. Okay. So this is a summary. Oh, there's one more way we can get them, which is relative access to education. And I want to highlight that if you see data that shows high wages in urban areas in developing countries and low wages in rural areas, it is not necessarily about differences in productivities. What it tells you is that either there are differences in amenities or there are differences in movement costs. Now, we can use this to try to then say, okay, could we work out which of these issues is causing the gaps between rural and urban wages in developing countries? And these are the results of a lovely paper by Doug Golan and some of his co-authors. So what they've done here is DHS data now tells you where someone lives. It has a geocode. And you can combine that with data on density at each of those geocoded locations. So I'll show you some of this later, but the global human settlements layer tells you the density of different locations down to GPS pixels. And then we can just look at the correlations between population density and some things like private consumption, public goods, crime, and air pollution. So what we would expect, given what I've shown you earlier, is people living in denser areas have higher private consumption. And we'll see here that that's the case. People living in the lowest quartile of density, Q1, they are only 40% of them are likely to have a finished roof on their house. Those who are living in denser locations, 8% of them have a finished roof. So we've seen that already. Cities have higher personal wealth, personal consumption, etc. Now, if we thought that our wage gaps were driven by amenity differences, we would want to then start to see that those private consumption differences are offset by some kind of lower level of something else, something publicly provided or something environmental. So we can have a look. First of all, we'll look at public goods. For some reason, given what I did to the table, we're going to look at it twice, but that's fine. So for example, in the least dense areas, about 40% of people in this data have access to electrical grid and 72% in the most dense neighborhoods. So that is not an amenity differential that could offset the gain from the wages of moving into cities. Let's look at crime. Let's look at air pollution. This is not necessarily a public good, it's an environmental factor. And it tends to go the same way. People who live in cities in this developing country data live in cleaner environmental spaces than those who live in non-dense populations. The only thing for which it goes in a compensating direction in this data is crime. There is, in this data, slightly more crime in slightly denser locations. Is that increase in crime enough to explain the large wage gaps that I showed you earlier? The answer, unclear. Okay. The paper Golan et al. That I'm taking it from suggests no. It would have to be that people really, really hate crime in a way that we don't think they do. There's an interesting thing in this data as well, which is, to me, it is not a surprise that public goods are easier to provide in cities. If I think about trying to provide an electrical grid in a sparsely populated rural area, I have to spread the fixed cost of setting up the grid over a very small number of people. Each person requires more poles, more wire, etc. Whereas if I want to do it in an urban area, I have a very dense, large population to spread fixed costs over. So this data in some sense doesn't surprise me, and again suggests that I think it's hard to explain urban-rural gaps just with public goods here. Okay, so that was our second use of our model. We used it to motivate looking in data for explanations of these wage gaps, and we are left kind of with thinking that our go-to explanation is the migration frictions that we saw were larger in developing countries than in developed countries. Okay, but there could still be variation in human capital. Okay, a third thing we would like to do with our model is to make some predictions. And the one that I'm going to concentrate is migration and climate change. Okay, if we're going to have a prediction, we're going to need to make prices endogenous. If I am going to think about climate change, prices will change. If a lot of people move from a rural area into a city, that will likely put downward pressure on wages in that city, upward pressure on house prices in that city. Similarly, if I want to make policy predictions, I'm going to need to do this as well, but we'll look at that in a second. So we typically make some very stark assumptions when we do this. Here are some examples. So we think of the productivity or the wage per unit of human capital in location D as just being a function equal to the productivity of labor in that location. And then we assume that as more people move in, there's an agglomeration externality. This gamma is greater than 1. So we have a combination, a competitive market and a very simply modeled externality. We do something similar for rents and other things as well. Now, in principle, the spatial model I'm talking about is infinitely flexible, and I could throw anything in that I would like, but I have 3 constraints. It has to be tractable. I have to be able to play with the model. If I have an alternative where I have thousands of parameters, that's going to be complicated to work. I have to only introduce things where I could at least plausibly measure the parameters I've introduced. To make use of this, I need to measure gamma in order to make predictions. So again, if I have thousands of parameters in here, I won't be able to measure them. They need to be able to touch data. I'm not going to tell you how to measure gamma, and in fact, it's extraordinarily hard, even with this. Finally, I want interpretability. So the reason, well, one of the reasons here we're assuming competitive markets is because if I use my model and to measure things, then I can interpret some of the outputs as measures of productivity. If I give up on competitive markets, then wages don't tell me about productivity, and then it's hard to make predictions about how GDP would increase or decrease as people move across space. Okay, so with that, let's have a look at what you could do. No, I'm not going to do this. Okay. Now, let's look at some wonderful work that uses these kinds of models to make what I think are extraordinarily important predictions about extraordinarily important question. This is an output of a data much more complicated than the one I've shown you, but still in the same spirit of spatial equilibrium. Okay, so from a paper by Cruz and Rossi Hansberg, it's just out in the Review of Economic Studies. And what does this chart tell you? It tells you where people are going to move away from and toward in response to climate change. It is a prediction about the migration responses to climate change. Now, we know that climate change is a spatial phenomenon, and what this prediction is that people will try to move away from hot locations and towards currently cold locations. They will try to get out of Africa. They will try to get out of my home, Australia. They'll try to get out of South America, and they will head up into Canada, etc. This gives us some idea of the places that will need to prepare to populate and the places that will need to prepare to depopulate. It is a positive and useful prediction that comes out of these models. Here is a normative prediction. This is going to tell us what happens to people's welfare in response to climate change. We really want to know, is climate change really going to be an absolute disaster for us? How much money should we spend on trying to stop it? Okay. On the left is using their baseline estimated cost of migrating out of Africa. And countries in the blue are the countries who are worst hit by climate change, and those in the red are the ones that are most positively gain from climate change. And you'll see here again that what we see is strong negative welfare impacts on the people of Africa and South America, the poorer parts of the world, do worse. And there are places that have sort of in the region of 20 or 30% drop in welfare, but the model suggests that it's not a huge drop. Part of the reason is because the model predicts so much movement of people across space. So I can make this normative and important prediction with the model. I can also start to do some other things with the model. On the right, they ask the question of, well, let's suppose we made it a lot harder to leave Africa. What if we said, look, nobody is going to want to let Africans migrate away from Africa to the rest of the world as the continent warms? Well, then those countries will be made significantly worse off. In this diagram, this is how much worse are they made relative to the other diagram if I push up their migration costs. So Africa is made far worse. There is some loss in welfare to parts of Scandinavia because they do not get labor from Africa in these environments. Okay, so I think this is a very useful answer to a very important question. However, let me make some comments. It is, as I said, absolutely essential that we simplify the world in order to make these predictions. But how simplified should we make them? For example, in this paper, they take parameters like the gamma parameter, the agglomeration parameter that I talked about earlier. As more people move into a city, it becomes more productive. They take that from data from studies in the developed world, not from studies in the developing world. They also assume, as I said earlier, that markets, labor markets, are competitive. How far wrong do I go if I do these? Do I get the positive predictions of the model wrong? Do I get the normative predictions of the model wrong? Well, let's have a little look at what the data tells us about these two things in developing countries. I'm going to talk about density and productivity. The gamma parameter is a measure of how much as density increases, does productivity increase. On the left is a picture that I already showed you. These are within country definitions of whether a person lives in an urban area or a rural area. And they are country specific. So different countries have different definitions of what a city or a rural area is. And this shows the things I saw: fast urbanization in Africa and in Asia from a low base. On the right-hand side, Melanie and Kyra and I have put together some data from the Global Human Settlements layer that uses a consistent definition of urbanization. You are urban if you have over a certain population density. We'll see here that Africa is not behind the rest of the world in urbanization according to this definition. In fact, in 2020, Africa is about as urbanized as is Europe. And by 2030, it will continue to be that. We won't see this massive increase in urbanization. I want to highlight first that this data gives a very different interpretation and a very different narrative. I use the figure on the left to say urbanization is coming, we need to prepare for it. But the right-hand picture says urbanization has happened. Here's another picture that I showed you earlier, reinterpreted through the lens of density. On the left, we have a very commonly known or commonly talked about correlation. Places that are richer are more urbanized. On the right, using this density threshold, we see that that relationship is much, much weaker. What does this tell us about the gamma? What do we have to account for? The developing world has cities. It's urban by the density measure, but it still has large urban rural gaps. And from the nightlights data we saw, its cities seem to be far less productive than the developed world cities. Now, there are many, many possible explanations of those sets of facts. I'm intrigued to know them, but one explanation is that agglomeration, the productivity of living together, is just much lower in developing countries. When I go to a developing country, perhaps there are two separate labor markets, an informal labor market and a formal labor market. If we are combining all of those people in our density measure, then perhaps I'm overestimating how many people are in effect in the dense urban labor market. This will then mean using the gamma from a different country in our prediction is going to strongly underestimate the costs of migration into cities in Africa in response to climate change. Okay. Here's a second piece of data. This is from a nice paper by Emily Bretzer and her co-authors. I said earlier that the models tend to assume that products markets and labor markets are competitive, so people are paid their marginal. Well, what does this experiment do? On the left is wages during the lean season, that is post-planting pre-harvest in rural areas in India. And on the right is the same wage data in a different time of year where there's more demand for labor. And what do? They have an experiment. In the control group is business as usual. That's the red line. And in the treatment group, they give about 35% of the urban labor market, rural labor market, a job outside of the village. Okay? This sucks a huge number of people out of the labor market. If labor markets are competitive, that must mean that wages would increase. The value marginal product of labor should go up for those that remain in the village. And what we see is during the lean season, there is no impact on wages. Wages during this period are not set competitively. They are subject to a floor. They have a different paper perhaps explaining what's going on here. Now there is, and we can see that in principle, labor markets could work. On the right, when there's a more busy season and wages are above this floor already, we do see that sucking people out of the labor market. This tends to suggest that at least in this context, the assumption of perfect markets, perfectly competitive labor markets, is not going to be the right one in India. What I don't know is what happens if I alter that model and I try to repredict the costs of climate change. Do I get them vastly wrong or do I not? I think we need work that takes these kinds of development economists, careful data collection and experimentation and combines it with the modeling to try to make better predictions here. Okay. Finally, I'm going to look at one policy question. The question is there too much migration? And I apologize for the typo with the two. Okay, so here's a little model, one final little thing to think about before we're done. So this is a model of a world. It's a species of the spatial model I've already given you, where there's just an urban area and one city. Okay, we're going to assume there are no costs of moving and that everyone is the same. So we no longer have these epsilon shocks. Now, this solid black line is the real wage of somebody living in the city. Why does it have this shape? Well, two reasons. First of all, we tend to think that as people move into cities, we see agglomeration externalities and that pushes up their productivity. They are able to engage in activities you couldn't in a less dense environment. For example, open factories. That means that this is going to be upward sloping. The real wage is going to go up for at least some period. Now, if you think about it, if the real wage goes up forever, then the more people move into the city, the more people will want to be into the city. So the more people will move into the city, so the more people will want to be in the city. And we will end up with just one gigantic city and nobody living in rural areas. That is not the world we live in. So it cannot be that the real wage just goes up in the city as more and more people move into the city. How can we stop that? Well, what we're going to assume is that initially we have agglomeration, people move into the city, that increases productivity, and everybody is made better up, putting up real wages. But eventually the city starts to run out of land. That means that commute costs increase, people are crushed, or people have to live so far away from the city centre that their commute times become very high. Also, because of the demand for land, housing prices rise, and these congestion externalities start to dominate. That means eventually the real wage starts to drop as people move into the city. So that explains why city population gives an inverse U relationship with the real wage. Now, I can put on here the rural wage, and I'm just going to assume that there are competitive markets in rural areas, despite what I said earlier. But it's going to work with this model just for a bit. So we can have a little think about how many people then move into the city. I'm going to want to move into the city so long as the city has a higher wage than the rural area. Now let's have a little look. Well, if I'm at this unstable city size, then people would be indifferent between living in the city and living in the rural area. That could be an equilibrium. But now let's tweak it a little. Suppose that Ollie moves into the city when he was in a rural area just for fun. That's going to push up the real wage in the city, and that's going to draw more people into the city. And when those more people move in, we're all going to move to the right in this diagram. That is not a stable equilibrium. Then on the right, we have a stable equilibrium. That's where the rural wage is equal to the real wage in the city. People are indifferent about where they live. Some people stay in the rural area, some people in the city. And this is stable. If I bump this around, I don't get this explosive behavior that I've just looked at. Now, this stable equilibrium in this model, this is inefficient. We can look at it. And the point that optimizes the welfare of the city residents is to the left here. The actual optimum is somewhere between the stable and the optimal for the city residents. And so we have this strong prediction from the model that cities are too big. Now, as I said earlier, I get this comment constantly when people ask me about migration, and people don't like migration into developing world cities. Perhaps the model suggests that's true. Now, I want to just say one more thing about using these kinds of models to answer these kinds of questions and what we need to do. I have drawn here a different curve. This is a dotted U-shaped curve that I've labeled perceived wage. Let's suppose that those in rural areas perceive the real wage in the city to be lower than it actually is. I've drawn this curve below the black curve. You'll see here that it intersects with the rural wage at city size A. This is a city size that is smaller than optimal and where we would want to encourage migration. Why might the perceived wage be lower than the real wage? Well, this is data from a lovely experiment by Travis Basler, one of Melanie's students, from a couple of years ago. And here is information on the left. These are beliefs of people surveyed about wages in different cities in Kenya compared to actual wages in those cities in Kenya. And you'll see that people massively, all these people live in a rural area. People massively underestimate what the real wages in cities are. Why? Well, on the right, we have further data from the paper. The light grey are parents' reports on what they believe their children earn. And on the right, in the darker grey, is those same children's reports on what they actually earn. So if your child lives at home in the village, the parent and the child report the same income. If the child moves to the city, they report a much lower income than they earn. Why? If I tell my parents the income I earn, then they're going to want some of it. Or they're going to send my brother to live with me that I may not want. And this is going to mean that people systematically underestimate the gains of moving into cities. What we need to do is understand whether these effects are large enough so that we're to the left of the optimum and cities are too small, or to the right of the optimum. We can't just use the models without adapting them to developing countries' specifics to answer our big questions. Okay. That's the same point I made earlier. Okay, so a summary of what we've gone through. Understanding a migration is, I think, important to understanding key development questions. What will happen with climate change? What explains spatial inequality, and what could we do about it? Should there be more small cities or a larger number of big cities? Spatial models are essential to answering these questions. For example, we can't take just a reduced form data collection approach to extrapolate what climate change will do. We have to have a model. But developing countries are characterized by market frictions that are not currently in those models. So we need more work that combines the best of both worlds. In-country, data-intensive measurement of market frictions, that is the hallmark of development economists, combined with spatial modeling, that is the hallmark of urban economists. Okay, I'm done. Sorry that went slightly over, and thank you very much for listening if you did.
Jared, thank you very much. And I think we started at 3 minutes past, so you were bang on your 60-minute allocation, I'll at least say. No, I really enjoyed that and appreciated that. Thank you very much for, verbalizing your joint lecture with Melanie. And Melanie, thank you very much for answering questions throughout the Q&A. I think, as I said, I enjoyed that. And I'm not just saying that because I'm contractually obligated, but I think to hear one leading scholar on migration while also having questions directly answered from another leading scholar in migration is like a real privilege. And I'm really happy that we managed to do that with this IGC BREAD series. Now, we're not over yet. We're on to the Q&A part of the lecture. So for you participating live, please raise your hand so that we can bring you in with questions. I did kind of indicate I was going to slightly bias towards that. There are also a number of questions that Melanie has particularly indicated she wants to answer live, so I'll be able to come to that. And for those in the chat, please also kind of upvote questions. I've taken note of the most upvoted thus far, but of course there is some time for that. Good. We have 2 hands here, which I will start with. And please, we don't want another mini lecture, so if you could please keep your questions short. Masood, I think you had your hand up first, so Greg will unmute you, and if you can ask your question, Melanie is here to respond.
Yeah, hi everyone. I'm Masood from Rice University, and I have 2 questions, 2 short questions. How can you account for intra-generation effects on this migration patterns? For example, we see different countries' age pyramids change, and we see some kind of migration from rural areas to the urban areas or even between cities. But then after we observe that the pattern of this age pyramid change, there is no reverse migration from, for example, urban areas to rural areas. That was caused basically on the productivity of urban areas for example, young people. But after the change in the pattern, we don't see reverse migration. And my second question is that in your model,
I didn't quite understand. Could you just repeat it? The question is about age patterns of migration between rural?
No. In intergenerations, for example, my dad moves to a city because city.
Why don't we do one question at a time, just because we have 30 minutes. So let's answer that one. So what you're seeing in general is the patterns of migration. On average, people are moving rural to urban over time. However, there's actually a surprising amount of backward and forward migration. So Alan Young has a paper about this using DHC data across a lot of the world. In our Indonesia paper, Garrett and I look at this in particular. And what we see is that, for example, in Indonesia, if you start in a rural area, about 40% of the time you go to another rural area, and the rest of the time you go to an urban area. However, if you start in an urban area, 25% of the time you're actually moving to a rural area. So how we rationalize those patterns in our paper is that on average, urban areas are more productive. On average, most people are going to be going towards urban areas. However, there's a lot of individual specific, you might have preferences, you might have skills. So just because on average there's going to be movement towards urban areas doesn't mean that every person will go. And that's exactly what you see in the data. You sort of see backward and forward, even though the overall trend is moving there. And that's what we see in the data in Indonesia. It's also what Alwyn Young sort of documents a surprising amount of kind of reverse migration, people moving backwards once they start in urban areas. And then that in the model would be preference shocks or productivity shocks to kind of rationalize that.
I will just say one other thing in response to that, which is that there is a clear need to update everything I've just said with more careful thinking about time. That includes intergenerational, that includes how people respond over time to differences in wages across space. I think that's a great area to work, and there are some dynamic models, but they haven't really been adapted to try to answer the questions that we're looking at this.
And I think one other thing which is very difficult is also probably data. So I think I answered one question in the chat, which is that how do people measure migration? Ideally, you would have panel data where you see someone move. Most of the time, we don't have panel data. So what we're looking at is repeated cross-section data where you ask someone where they were born. However, the stuff about intergenerational mobility, it needs even more data because you need to know something about who are the parents of the kids. So I think some of that work, where I think there's really interesting work about intergenerational mobility and migration is historical settings where you're able to link census data, where you have like the individual names of people. And so you can look, for example, at some of Ran Abramitsky's work where they're linking data in the US. There's similar work in Argentina. However, that requires countries that have census data where you have the names and you can do all of the matching, and that's a really restricted number of locations. So I think these are really interesting questions, but you need to think about how you would get to even observe, can you put in questions in your modules about where were your parents born, where did your parents live, et cetera, et cetera. Maybe that would be one way to start capturing some of this intergenerational mobility.
Nice. Thank you, Melanie. Masood, we will come to your second one if we have time, but I'd like to try and spread the questions as much possible. Mumita, you were up next. If you'd like to come on video and share your question if possible. Thank you.
Hi, thank you so much. My name is Momita.
Mumita, could you speak a bit louder or closer to your microphone? I think if anyone's struggling slightly to hear, that would be appreciated.
Sorry, is it better now?
Yeah, that's better.
Okay, sorry about that. My name is Momita. I'm a PhD candidate at UC Santa Cruz, and I'm currently working with panel data on short-term temporary migration in India. And I guess my question was around how you would tweak the framework that you just presented to account for movements that are temporary or short-term in nature. And even if you do, like in terms of like downstream implications or interpretations, like what would you sort of try and think about in terms of like how this is different from people permanently like taking their whole families and shifting into cities or whatnot. But like if to the extent that we understand that temporary migration also happens and is somewhat different, like how would you think about structuring this model or tweaking it and like downstream implications of that?
Yeah, that's a really good question. Someone had a similar question in the chat that I answered. One thing is, this is sort of a spatial equilibrium model. And generally, we think that spatial equilibrium takes a relatively long time to happen. So these are sort of models that most of the time people estimate using, say, 10-year census intervals. Not always. And so they sort of, we think that there's some really big shock, there's migration in, it takes a little bit of time for wages and labor markets and housing prices to adjust. There's nothing that says in the model that it has to be like that, but you kind of get back to this point that Garrett just talked about, which is maybe there needs to be a little bit of a process about how is there a transition or how is there a dynamic? And at the moment, the static model doesn't really have that. So I think seasonal migration is really important. Quantitatively, we know that a lot of the flows of households, sometimes the order of magnitude of seasonal migration is much larger than permanent migration. And so it would be really interesting to think a little bit about, is it partial equilibrium that we want to be studying? Is it the general equilibrium? Like the spatial model lets us really get the general equilibrium across states. You know, and how do we think about the adjustments in general equilibrium at a shorter time frame within the year? So I think these are really, really important questions. But there's not currently like a great, you'd have to think through, like, how do you model the timing? How do you model the adjustment? You know, do you assume that everything perfectly clears and it's in a new equilibrium, or is there something that goes a little bit more slowly? So I think that's a really interesting area to work on.
Just one comment on papers is, one thing to say is that I think that seasonal migration and temporary migration, in the model I presented, people are trying to improve their lives forever. Seasonal migration and temporary migration, I think, are about removing risk. So I'm trying to get the best of both worlds by being in both places. And there are a series of papers around that. There's a very nice paper by Kevin Donovan, who's at Yale University, where he's trying to think about the impact of transportation improvements on the ability of people to use that kind of behavior as an insurance. Now, that model is not a full spatial equilibrium model. You'd have to bring that into this sort of environment. And one thing that you hear a lot is that temporary migration makes it rather hard for firms in cities to sort of optimize their choices of labor. So you hear a lot about, you know, people coming for a while and then leaving, and that makes it hard to train. And I think that's, for example, one element that would have to be in a model to get a realistic understanding of those sorts of issues. But it would be exciting to try and do that, I think.
Nice.
Thank you.
Thank you, Gareth. I did promise at the beginning I would be a quasi-democracy, so I'm going to take the highest upvoted question now, and then we're going to ask another couple from the chat that I think you indicated you wanted to answer live, Melanie. But the highest voted one was from Asad Shoaib, who'd asked, can you please speak a little on the urban slums, why people don't have higher consumption, no housing provision, limited public services, higher crime, more unhygienic living conditions, for example, the urban slums in Rio and Mumbai?
Yeah, so I think on the reading list Garrett and I and Kara just finished writing a handbook chapter. And what we've done in the handbook chapter, which has a lot of the material from Garrett's lecture now, but what we then do is we look in detail at each of the components of this indirect utility. So for example, there is wages. And so Garrett talked a little bit about the labor market. There's housing. How does the housing market work? Is the housing market formal? Is it informal? You know, in these models, we would maybe want to think about what happens when more people move in. Does it increase the price of housing? How do we think about modeling the housing supply elasticity, for example, when the housing market is informal, like the case of slums? So what we've done in that paper is we sort of summarized a lot of the literature about what are the quality of the houses that people live in, and then also thinking about what are some of the other consumption durables that people have. And it is the case that people are living in low quality housing when they're living in slums, and something like 50 to 60, maybe 80% of urban households are living in what the UN defines as a slum, which is about the quality of the house. However, when you go and look at the same definitions of house quality for rural areas, it's also the case that a very large proportion of households in rural areas don't have, for example, finished roofs or finished floors. By that definition, they also have slum housing, although most of the focus is on urban areas. If you look at, for example, sanitation, there's often more sanitation in urban areas than rural areas, despite there being sanitation gaps. So a lot of this discussion is kind of coming back to the idea that when people are making decisions, are people making decisions, like are the amenities in the city objectively worse than the amenities from where they're coming from? And that might be for the quality of the house, it might be for congestion, it might be a bunch of different things. And what's one kind of striking fact is across a lot of different outcomes, it's quite hard, especially in the data across many African countries, to find that there's any lower level of amenities in urban areas and rural areas, even once accounting for housing quality. So it is the case that lots and lots of people are living in substandard housing. But it is also the case that that's sometimes both a rural phenomenon as well as an urban phenomenon and not a differential phenomenon. And so the question then is, what's the process at which those housing, is that an income effect? Is that a property rights effect? What's the process at which people would be able to have improved housing? And is there constraints that might be different over time in urban areas versus rural areas? So if you take a look at our handbook chapter that I think is on the reading list, we've tried to kind of summarize a lot of that literature. And I think there's sort of a really big puzzle on, are slums something that a country grows out of over time? Or are slums kind of more of a poverty trap where it's going to be really difficult for that to change over time as the country gets richer? And there's different historical cases there, thinking about, for example, what happens when there's a lot of development. This Nick Sivandis has this Urban Mills paper in Mumbai where they're looking at what happens to slum neighborhoods when there's a lot of new development. Do the slum neighborhoods change and become formal property? If that is right, what happens to the people that were living in those locations? So I think it's a really, really interesting set of topics. And I think I'll refer you to the handbook chapter for like a discussion and a lot of references there to read up.
Thank you, Melanie. Jefta, we're going to come to you in a moment, but I just want to go to two more in the chat. We're going to go back to somewhat benevolent authoritarian dictator, and I'm going to pick two that are both highly voted, but also Melanie would like to answer live. So one is from Ryan Key, which is asking with regards to cross-border migration, how is internationalization, built into this model, particularly in forms of this kind of COD, thinking about migration costs and what are those other frictions that might apply, I suppose, across national boundaries. And the other one was from Aisha Khatoon, who was asking, I think particularly, and I know some of your other work looks at kind of the climate change migration drivers. So what are these kind of specific climate factors that affect significant migration? And I suppose, how do they vary? Extreme temperatures, floods, droughts, earthquakes. Do we view these shocks differently from these kind of stresses? So there's two there, Melanie, and then Jeff, I'll come to you for a live one.
Yeah, so I think those questions are a little related. So the idea of a model, when economists are putting something like the spatial model, the idea is that this is just a tool to help us try and simplify how we understand the world. So lots of the comments that I answered in the chat were things like, well, how would we fit culture, for example, into the model? And, we didn't have specifically a culture term, but we did have an amenity term, and we did have a migration cost term. So one way you can think about is the model, it's very simple, but is there a way to think about how to incorporate other channels as part of the migration costs or, as part of the differential amenities, for example? So thinking about the international case, I think, is a really nice example. There's nothing in the model that means that the same model can't be a model across countries. However, we might then want to think a little bit about what is something like migration costs. Often when people look at migration flows across countries, what you do is you say, okay, let me look at how many people are moving from, I don't know, Tanzania to the United States. I'm going to compare that as how many people are moving from England to the United States. I'm going to correlate that with distance. And then I'm going to say, okay, one factor that might be the difference is that Tanzania is just further away than England. And that's the reason that people are not moving. That's the migration cost. That could be part of the factor, although there's really likely many other factors, like how likely can you get a visa, or how all these other political economy factors. So I think when you start thinking about putting the same model across countries, you have to start thinking about how is that migration cost term determined? And if you're thinking it's only distance, is that realistic, or is there an interaction with, for example, policy? And then thinking about climate change, is it the case that that relationship between migration costs is going to stay stable, or a country is going to perhaps become stricter? Is the US, for example, going to reduce the number of visas it has? So the migration costs might be a policy response that would even increase. And so over time, we would want to be really careful about predicting how many people would be able to migrate, for example, from Tanzania to the United States, using the historical relationship between distance and migration flows, if it's the case that that's a policy variable. So I think what I'm trying to say is that the model by itself is just meant to be like an idea to how to structure your ideas. But when you want to think about applying it, for example, to something like climate change, it might be really important to think hard about what do you think is going to happen to migration costs? Is it reasonable to take migration costs as stable? Is it reasonable to just say the only component of migration costs is distance? Or do you want to think a little bit more carefully? And that might be one reason. I think that doing these models across countries is a little bit more difficult than doing migration within a country. Because migration within a country, with a couple of exceptions, for example, China or Vietnam, people are usually able to freely move. So we can think about, for example, measuring migration costs as something that's probably much more closely represented by distance rather than political factors. And I think the same comment comes back to thinking about climate change shocks. So in the model, we have something about income. We have something about how nice a place is to live. And then we have something about the costs of getting between locations. And then we have in the background, how do all of the markets clear? So how is it that we would be in a stable equilibrium when people move in and move out? So something like climate change, you could just think again about how to slot it into that model. So climate change might be a negative productivity shock in certain rural areas. So that's going to come into the wage. It might be, as Garrett showed, there's some places that are going to have a positive productivity shock. And so that would be a really simple way to model it would be relative productivity changes in different locations. And then you might want to think a little bit about what is the way that the labor market's going to clear in those locations. Do we have something where we think there'll be agglomeration benefits? So having more people move to the city might actually be really good. Or is it that we might have decreasing returns to labor, where each additional person reduces is less productive and wages fall, sort of standard general equilibrium things. So I think what we kind of want to show here is that there's nothing that's really constraining the model. The model is just a starting point, and it's a really simple tool. But for lots of these ways to think about policies, like what happens if you build a new capital city? What happens if there's climate change? What happens if you build new highways? What happens if there's some really differences in language within the country? All of these things can most of the time be kind of translated to one of these components of the utility, and that just makes it a really easy way to start to be organizing your thoughts and trying to be a little more logical about how to map policies to something in the model. So I think these are really good questions. And I think a lot of the time you can just think, what would this shock do in the indirect utility? And then what do I think might be the responses that people have to that type of shock? So thank you.
Thank you, Melanie. Okay, Jepta, we'll go to you as promised, and then I have a question that I will also pick from the chat that I think is important for future research in this area, which I'll come to afterwards. But Jepta, please, over to you.
Yeah, thanks, Oliver, for the question, for the chance, and then Melina, and then Brian. Thank you so much for the discussion. I just have a quick question on. Well, my name is Jepta in Toronto here in Canada. Just from a policy perspective, so how can cities in these developing countries balance a rapid urbanization with sustainability? And asking, especially in the context of growing informal settlement and this kind of environmental factors such as degradations in these developing economies. I was wondering if we could fine-tune this and see where, especially ensuring where inclusive economic growth and equitable access to resources are available. How do we consider this? I don't know if it's clear.
Yeah, that's really interesting. I mean, one thing that's kind of interesting to think about is, so for example, in estimates in the US, cities are more environmentally friendly because people are generally denser, people can walk, they use less resources, so you can think a little bit about and when you're thinking about environmental sustainability, urbanization, are those two things necessarily in conflict? You end up having dense markets, you can end up thinking about how people can, for example, use less transportation if they're able to walk, if they're able to get around with public transportation. All of these sorts of things can be a benefit about why cities can be more sustainable than, living, for example, in really just spread out suburbs or really isolated areas. I do think that you want to think, maybe your question also relates a little bit to inequality in the city. And I think there, we don't have a good, and this model, the simple model by itself, there wasn't too much kind of discussion of inequality, and you could think a little bit about what sort of inequality are you sort of thinking about, and how does that map in there? So for example, one easy way you would get inequality in that model is we had, and I'm going to talk about it in terms of the model because I think it helps just to structure ideas, and it might also show like where there might be gaps in the model. So in the simple model that Garrett talked about, there was sort of everyone got the same wage when you went to the city. And the only difference across people was this preference, this sort of draw. Like I might have a really strong preference for sunshine, so I want to live in California. Someone else might have a strong preference for, I don't know, really dense cities. They want to live in New York City, something like that. That preference drawer. So if the model is really just a preference drawer, then there's no variability in people's income in the city. Like, and if that model is true, everyone has exactly the same wage and they pay exactly the same rent, right? That's clearly not true in the data. Like there's a big variation within the city. So the other way that you could think about modeling it is you could think about, okay, maybe we have two types of people. We have like more educated, less educated. What you would then have is you would have something that's an average between the groups. But again, you would have within the group, it's going to be everyone has the same income like this. And that's probably also not true. So Garrett and I in our Indonesia paper, instead of thinking about that shock as a preference shock, we think about it as a productivity shock. So what that means is that I'm going to get paid more if I'm in the city, if I'm more productive for that city. So this would generate some heterogeneity across people. But then the sort of right way to think about the inequality in the city is it still the right decision? Maybe I'm someone who's just got low productivity anywhere I go. So is the right comparison me against a high productive person, or is the right comparison me against what I would earn if I was in a different location? And maybe even though there's still a variation of income in the city, the counterfactual of me earning less in a rural area still means it's good for me to go there. Cities draw in whole lots of people, even though we have like folks earning really high figures and folks making really little income. It's still more productive for the people making little income relative to their outside option. I think those are the sorts of ways that you can start to think a little bit about inequality. And then the other question would be, is there actually a friction about inequality that we haven't modeled? And if so, what does that look like? And how does that go? So for example, something in our handbook chapter, we sort of document in our data in Tanzania and Dar es Salaam, 40% of people are walking to work. Is that because some households don't have enough money to take the bus? And is that inequality meaning that people don't have resources to fully access all of the labor market? That would be a friction where people are in a city, they could have access to better jobs, they don't have income, they have to walk. If you have to walk, you can only go an hour from your house, you can't maybe go to all of the places. That might be a friction where it's inefficient to have people not able to fully participate. And then you can say, okay, what does that mean? Do we want to subsidize public transportation more? And is that the reason that inequality in this case has got some negative impacts for the economy? So I think inequality is really interesting and really broad, but we might want to be kind of a little more precise. What exactly do we mean? And is it something about differences in people, or is it something that's driven from frictions or imperfections in some sort of market that would have a policy response?
Thanks, Melanie. I do have a question that I think will take you 10 seconds to answer, and I have one that will take Garrett 10 seconds to answer. And I do think it's an important question to ask, considering the cohort that we have here. This is from Demetria Freitas, and it was, quite simply, what software do you use to simulate these models? What is kind of state of the art?
Oh.
And Garrett, I have a real tee up for you, which is, if I was a PhD student wanting to research migration, where could I find important policy relevant questions to answer and get funding to answer them? So please, 15 seconds each, and then I'll close.
So we have code to do we have code for estimating all of the spatial models in MATLAB. The code, if it's not on my website, it's going to be attached in our paper and proceedings. We have a paper and proceedings paper on gentrification. All of the MATLAB code is in the supplementary files there. Steve Redding also has MATLAB code available. You can just download the toolbox from his website. These models are going to be like a little bit more complicated, so you might want to strip them down, but I personally use MATLAB to simulate these models. You could use R, you could use anything open source.
And in answer to your question, the final question, Ollie, the answer to that question is that the IGC is your friend. So the IGC has country economists working in a wide variety of cities around the world. They will have ideas about what are policy relevant questions in each of those cities and in each of those countries. They will have connections to government, and they will very happily share some emails or get on the telephone for you. If you have an interesting research question, they have, I think, up to £20,000 to put people in developing countries to start thinking about data collection, to start talking to policymakers, etc. And then we have periodic calls for proposals in which you could get a very large amount of money building on your beginning research. And so I think that's by far the best way. And, you know, I use the IGC, I get to talk to, say, mayors in developing countries, and they ask the most spectacularly interesting, difficult to answer questions. And I think it's a wonderful source of inspiration for doing research.
Wonderful. Thank you, Gad. And a timely and positive message to end on, but end we must. So yeah, thank you everyone. Well, particularly thank you to our speakers today, Gad, Brian, and Melanie Morton. I really appreciated your time. Thank you also to all your wonderful questions. I'm sorry we could not get to them all, but I think we've tried to get to them in a sufficient way that balances all the different tensions and time limits. All I'm going to do is close, but just say we look forward to seeing you next week, where we have Vernon Henderson and Maisie Wong on land use, markets, and planning, or as we're calling it, the physical city. And it'll be chaired by another wonderful economist from Cities That Work initiative here at the IGC. So you'll get a new face to and a new moderator. But with that, yeah, thank you very much, everyone. Thank you for staying the extra few minutes. It's much appreciated. And yeah, look forward to seeing you soon.